In this video here, we'll be looking at how to prove this trigonometry identity. So we have cosine to the power of 4 theta minus sine to the power of 4 theta over sine squared theta cosine squared theta equals to 4 cotangent 2 theta cosecant 2 theta. So now you look at here, all the angles here are in terms of theta and all the angles here are in terms of 2 theta. So very likely we need to make use of the double angle formula. Okay, so let's get started to prove this trigonometry identity, which is a common question that is tested in your O-level additional math exam. Alright, so we are asked to prove this identity, and we know that we will most likely need to use the double angle formula. Reason is because, okay, there is a double angle here, and these are all theta here. Alright. Right, so let's take a look at our double angles formulas that we have. Okay, so we know that we have double angle formula like sine 2x equals to 2 sine x cosine x. We also have another double angle formula here, which is the cosine 2x, which is equals to cosine squared x minus sine squared x, which is also equals to 1 minus 2 sine squared x, which is equals to 2 cosine squared x minus 1. We also have tangent 2x equals to 2 tangent x over 1 minus tangent squared x. Right, so these are the formulas that you see in your formula booklet. So let's see which ones are the ones that we can apply to prove this identity. Okay, you can do this by starting from the left-hand side, or you can also do it by starting from the right-hand side. Both you'll get the answer. So let me show you how to prove this identity starting from the left-hand side. So I start off with the left-hand side. I have cosine to the power of 4 theta minus sine to the power of 4 theta equals to sine squared theta cosine squared theta. Once I see sine squared theta cosine squared theta, okay, it reminds me of this, right? Okay, so how do I get a square? Well, I simply need to square this portion here, right? Now, so if I were to square this here, this identity here, I'll end up having sine squared 2x equals to 4 sine square x cosine square x. Okay, and therefore, if I'm only looking at sine squared x cosine squared x, then it is equals to 1/4 sine squared 2x. Okay, and this is what I'm going to change this portion here to. So I'm going to change sine squared theta cosine squared theta into 1/4 sine squared 2x. All right. Okay, next, I have cosine to the power of 4 theta minus sine to the power of 4 theta. So when I see something like this, it reminds me of a squared minus b squared. But now instead of having a squared minus b squared, I have a to the power of 4 minus b to the power of 4. Okay, so remember when you have a squared minus b squared, you have a plus b, a minus b. So now for this, instead of having a plus b, a minus b, a to the power of 4 minus b to the power of 4 will be a squared plus b squared times a squared minus b squared, right? So taking a look at this, we know that cosine to the power of 4 theta minus sine to the power of 4 theta can be changed to cosine squared theta plus sine squared theta multiplied by cosine squared theta minus sine squared theta. Okay, and if you have to take a look at your formula booklet, once you see cosine squared theta plus sine squared theta, we know that it is equals to 1, right? So we switch this to 1 and we'll be left with cosine squared theta minus sine squared theta. And cosine squared theta minus sine squared theta is equals to cosine 2 theta, right? So we can change this to cosine 2 theta. So I have 1 times cosine 2 theta, which will give me cosine 2 theta over 1/4 sine squared 2x. Okay, so now 1 over 1/4 is 4. So I've simplified this portion here. It will be equals to 4. Then I have cosine 2 theta over sine 2 2 theta, sorry, this is theta, not x, 2 theta, okay, and I still have 1 over sine 2 theta. So basically what I did is I changed the sine square 2 theta to sine 2 theta times sine 2 theta. Okay, so I split it up into 2 like this. Okay, and I combine one of it with the cosine 2 theta and the other one with 1. Okay, the reason why I did this is because I need to show this, right? And cotangent 2 theta is basically equals to cosine 2 theta over sine 2 theta. Okay, and cosecant 2 theta is equals to 1 over sine 2 theta. So basically now I have reached what I need on the right hand side. So I have 4 cotangent 2 theta cosecant 2 theta, which is equals to right hand side, and therefore I have proven this identity.